Welcome to Science in 10 Minutes. The solar system awaits. Today we're embarking on a thrilling journey through our very own cosmic neighborhood, the solar system. Buckle up as we zip past planets, moons, and asteroids, all in a day's work for a curious mind like yours. Imagine a giant spinning disk of gas and dust swirling around a bright star. That's how our solar system formed billions of years ago. Over time, this dust and gas clumped together to form the planets, moons, and asteroids we know today. From the scorching heat of Mercury to the icy depths of Neptune, we'll uncover the unique characteristics that make each planet special. Next stop, the Sun. The Sun, a giant ball of burning gas, sits at the heart of our solar system. It's like a powerful furnace, radiating light and heat that make life on Earth possible. Without the Sun, our planet would be a cold, dark, and lifeless place. The Sun is mostly made up of hydrogen and helium. These gases are constantly undergoing a process called nuclear fusion, which releases enormous amounts of energy in the form of light and heat that travel across space to reach us here on Earth. Did you know that the Sun is so large that over 1 million Earths could fit inside it? That's huge. Even though the Sun is incredibly important to us, it's just an average star compared to the billions of others that exist in our galaxy, the Milky Way. But don't worry, the Sun is not going anywhere for billions of years. Now let's leave the Sun's warmth and venture to the closest planet to it, Mercury. Zipping around the Sun at an incredible speed, we find Mercury, the smallest planet in our solar system. If you could stand on the surface of Mercury, the Sun would appear 3 times larger in the sky than it does from Earth. Because it's so close to the Sun, temperatures on Mercury can soar to a scorching 800 degrees Fahrenheit during the day. But at night, without an atmosphere to trap the heat, temperatures plummet to a frigid -290 degrees Fahrenheit. One of the most interesting things about Mercury is that it has almost no atmosphere. This means that there's no air to breathe and no protection from the Sun's harmful radiation. Although Mercury might seem like a desolate place, it's a fascinating world with many secrets yet to be revealed. But for now, let's hop aboard our spaceship and travel to our next destination, Venus. Our next stop is Venus, often called Earth's twin because of its similar size and composition. But don't let that fool you. Venus is a world of extreme heat and poisonous air, making it one of the most inhospitable places in our solar system. Venus is covered in a thick, toxic atmosphere made up mostly of carbon dioxide. This thick atmosphere traps heat from the Sun, creating a runaway greenhouse effect that sends temperatures soaring to a scorching 900 degrees Fahrenheit, hot enough to melt lead. Beneath its dense clouds, Venus is home to a diverse landscape of mountains, volcanoes, and vast plains. While Venus might not be a suitable place for humans to visit, it serves as a reminder of the delicate balance that makes our own planet habitable. Now let's journey back home to our own blue oasis, Earth. Section 5. Earth, our blue oasis, in the vastness of space. Ah, Earth, our home sweet home. As we gaze back at our planet from space, we're greeted by the awe-inspiring sight of swirling blue oceans, vast green continents, and the delicate wisps of white clouds. Earth is a vibrant and dynamic planet, teeming with life and constantly changing. What makes Earth so special is its ability to support life as we know it. Our planet sits within the habitable zone of our solar system, also known as the Goldilocks zone. This means that Earth is just the right distance from the Sun, not too hot like Venus and not too cold like Mars, allowing for liquid water to exist on its surface. Earth's atmosphere, a delicate layer of gases surrounding our planet, plays a vital role in protecting us from the Sun's harmful radiation and regulating our climate. From the highest mountains to the deepest oceans, life exists in every corner of our planet. Now let's continue our journey to our next-door neighbor, the red planet Mars. Section 6. Mars, the red planet and dreams of colonization. Our next destination is Mars, our rusty red neighbor, which has captivated the imaginations of humans for centuries. Mars gets its distinctive red color from the iron oxide, or rust, that covers its surface. While Mars is much smaller than Earth, it shares some similarities, like its rocky terrain, polar ice caps, and evidence of ancient water flows. Scientists believe that Mars may have once had a thicker atmosphere and liquid water on its surface, making it potentially habitable in the distant past. Today, Mars is a cold and dry desert planet with a thin atmosphere. but that hasn't stopped humans from dreaming of one day setting foot on its surface. Space agencies around the world are actively researching and developing technologies for future human missions to Mars, with the ultimate goal of establishing a permanent human presence on the red planet. The exploration of Mars is not just about searching for signs of past or present life, it's also about pushing the boundaries of human knowledge and understanding our place in the universe. But for now, let's journey beyond the inner solar system and venture into the realm of gas giants, starting with Jupiter. Section 7, Jupiter, the king of planets, a gas giant. Prepare to be amazed as we approach Jupiter, the largest planet in our solar system. Jupiter is so massive that it could hold over 1,300 Earths within its swirling clouds. One of the most striking features of Jupiter is its Great Red Spot, a massive storm that has been raging for centuries. This storm is so large that it could swallow Earth whole. Jupiter is a swirling world of colorful clouds, arranged in bands and stripes, constantly changing and evolving. Unlike the rocky planets we've visited so far, Jupiter doesn't have a solid surface. If you were to try and land on Jupiter, you would just keep sinking deeper and deeper into its thick atmosphere, experiencing unimaginable pressures and temperatures. Jupiter has a faint ring system much less prominent than Saturn's, and a staggering number of moons currently estimated at 79. Let's continue our journey to another ringed wonder, Saturn. Section 8, Saturn, the ringed wonder, a jewel of our solar system. Get ready to be dazzled as we approach Saturn, the most visually stunning planet in our solar system. Saturn is best known for its magnificent ring system, an intricate and breathtaking spectacle that has captivated astronomers for centuries. Saturn's rings are not solid but are made up of countless particles of ice and rock, ranging in size from tiny grains of dust to massive chunks the size of houses. These particles are thought to be the remnants of shattered comets, asteroids, or even moons that got too close to Saturn and were torn apart by its powerful gravity. Saturn, like Jupiter, is a gas giant, composed mostly of hydrogen and helium. It's also a very windy place, with winds in its upper atmosphere reaching speeds of over 1,000 miles per hour. Now, let's venture further into the outer solar system to visit the ice giants, Uranus and Neptune. Section 9, Uranus, the sideways planet with icy mysteries. Our next destination is Uranus, the ice giant that's tilted on its side. Unlike the other planets in our solar system, which rotate on an axis that's roughly perpendicular to their orbital plane, Uranus spins on its side, with its axis tilted almost parallel to its orbit. Scientists believe that this unusual tilt may have been caused by a massive collision with another object early in Uranus's history. This tilt gives Uranus extreme seasons, with each pole experiencing 42 years of continuous sunlight followed by 42 years of darkness. Uranus is much fainter than Jupiter and Saturn, and is composed mostly of icy materials like water, methane, and ammonia, along with some rock and hydrogen and helium gas. Uranus has a faint ring system discovered in 1977 and a collection of 27 known moons. Now let's conclude our planetary tour with a visit to the last of the ice giants, Neptune. Section 10, Neptune, the distant blue giant with powerful winds. Our final planetary destination is Neptune, the farthest planet from the Sun in our solar system. Neptune is a cold and distant world, but it's a dynamic and intriguing planet with its own set of wonders. Neptune is similar in composition to Uranus, being an ice giant made up mostly of water, methane, and ammonia. It has a beautiful deep blue color, which is caused by the methane in its atmosphere absorbing red light from the Sun and reflecting blue light back into space. Neptune is a very windy place, even more so than Saturn, with winds in its upper atmosphere reaching speeds of over 1,200 miles per hour. These powerful winds whip Neptune's clouds into bright streaks and dark spots, constantly changing the planet's appearance. Neptune has a faint ring system discovered in 1989 and a collection of 14 known moons. Now let's venture beyond the planets and explore the outskirts of our solar system. Section 11, Beyond the Planets, Pluto and the Kuiper Belt. As our journey through the solar system comes to an end, let's venture beyond the 8 planets to explore Pluto, once the 9th planet, now a dwarf planet, and the vast Kuiper Belt, a region of icy remnants from the early solar system. Discovered in 1930, Pluto captured many hearts, but was reclassified as a dwarf planet in 2006. In 2015, New Horizons gave us a close-up look at Pluto, revealing a diverse world with mountains and glaciers. The Kuiper Belt, named after Gerard Kuiper, lies beyond Neptune's orbit, home to countless icy bodies. Thanks for joining me on this cosmic adventure. Don't forget to subscribe for more episodes of Science in 10 Minutes. Until next time, keep exploring.